Hey everybody, Elliot's right back to show you how to use unit circle to find sine and cosine values. Alright, one thing to remember is the x in an xy coordinate, the cosine, always the x coordinate, the sine, always the y coordinate. So, sine, 5 pi over 6. Sine is telling us that is the y coordinate. I then go to 5 pi over 6 on my unit circle, and I look at the y value. That y value is equal to 1/2. That means sine of 5 pi over 6, that is equal to 1/2. Next, cosine, 7 pi over 4. Cosine, that means x coordinate. So, I go to 7 pi over 4. That had the coordinate of root 2 over 2, negative root 2 over 2. It was cosine, so that's the x coordinate. And the x coordinate at 7 pi over 4 is positive root 2 over 2. Next, cosine, 210 degrees. Now we're working in degrees. So I go to the 210 degree point, and it's cosine. So I'm looking at the x coordinate, and at 210 degrees, the x coordinate, negative root 3 over 2. So cosine 210 degrees, negative root 3 over 2. Number 4. Sine 180 degrees. Sine, that means y coordinate. So I go to 180 degrees on unit circle. I look at the y coordinate, and the answer is 0. Hey, take a minute. I know you're not supposed to use your calculator this unit, but just type it in. Sine 180 degrees. Be amazed that the answer is 0. And then put the calculator away because you don't need it. All right. This brings in perfect vocabulary from the last couple days. Sine of negative 120 degrees. The problem is my unit circle here only works between 0 and positive 360 degrees. So let's use some coterminal angles to find a coterminal angle that is within 0 and 360 degrees. So on the side here, if I take negative 120 plus 360, that is positive 240. So because coterminal angles point in the same direction, I know that at 240 degrees, these two angles are pointing in the same direction, which means their sine values would be the same. So I go to 240 degrees, and it's sine. And at 240 degrees, the sine, the y coordinate, is negative root 3 over 2. Last one, cosine 400 degrees. That is not within my unit circle, so I look for a coterminal angle, 360 degrees, subtracted from 400. This problem's not going to work out. I need to change this. Let's change this to 420 degrees. And so if I look for a coterminal of 300 or 420 degrees, subtract 360 from that, you'd get 60 degrees. So I go to 60 degrees on unit circle, and I look for the x coordinate. That means sine or cosine of 60 degrees is equal to 1/2. Okay, that's one technique of doing this. Is using using all of these different values and finding unit circle that way. Another technique which a lot of people prefer is to use reference angles. And in reference angles, they don't have any of this, any of this, any of this, or oops, oh no, they do have that. They have these ones. Oh, I get so excited scratching stuff out. I forgot that I actually need this stuff. They keep the angles for the first quadrant on their unit circle, along with the 4 special case scenarios, but they don't write down any of the other angles. They have just the first quadrant angles, and you can do this. If you want to build your unit circle just like this, and not include this, this, or this, do less writing, you can, but if you do that, you need to include this, this phrase here, A, S, T, C. All students take calculus. That's how I learned it. There's other people call it different things. But anyway, how could you use reference angle to solve these problems? Sine 5 pi over 6. You think, what at 5 pi over 6, what is the reference angle? And at 5 pi over 6, the reference angle is pi over 6, which means sine of 5 pi over 6 is equal to sine of pi over 6. So then we only need to go to the first quadrant, see the reference angle answer, and it's positive 1/2. How do you know if it's positive or negative? Hey, Mr. Telling, all students take calculus. That means that in the first quadrant, everything is positive. In the second quadrant, only sine is positive. In the third quadrant, only tangent is positive. And in the fourth quadrant, only cosine is positive. Because this was sine in the second quadrant, these answers positive. Reference angles. All right, number 2, if I was using reference angles, cosine 7 pi over 4. If I think about 7 pi over 4, that's a reference angle of pi over 4. So if I go to pi over 4 right here, and once again it was cosine, that means this is equal to cosine of pi over 4. Or pi over 4 is right here. That x-coordinate's positive root 2 over 2. But how do you know if the answer is positive or negative? 7 pi over 4. Fourth quadrant, only cosine is positive. So the answer is positive. I prefer not using reference angle, but it works. Cosine 210 degrees. Cosine 210 degrees, that is third quadrant with a reference angle of 30 degrees. And if I think 30 degrees, x-coordinate, I get root 3 over 2. How do you know whether it's positive or negative? 210 degrees. Third quadrant, which means only tangent's positive, that means cosine must be negative. So negative root 3 over 2. I wouldn't use reference angle for number 4, I just use special case. 180 degrees, that's sine. Y-coordinate 0, that wouldn't change at all. Sine of negative, well actually I would do, for this one I'd still use coterminal angles, but then once you've used your coterminal angles, you then use your reference angles. You have a reference angle of 60 degrees, and it's sine. At 60 degrees, the y-coordinate's root 3 over 2, so I answer root 3 over 2, and then because it's third quadrant and only tangent's positive, my answer would be negative. Finally, if it's first quadrant, you don't have to worry about reference angle. Cosine 60 degrees, it's just 1/2. Whew! So 2 different ways to do unit circle problems. Now there's forwards problems, then there's also backwards problems. Solving equations. The instructions are going to read like this. Find the value, but or it'll have this S in little parentheses. Find the value or values of x or theta in the range of 0 to 360 degrees, hard bracket, soft bracket. Thanks, Mr. Telling. Oh, yeah, I got to get that signed. Or 0 to 2 pi. Okay, So solving equations. I'm just going to do two of these. Suppose it says cosine of theta is equal to negative 1/2. Now, one thing it's important to know, they're going to use different variables. If they use the variable x, we're typically in degrees, 0 to 360 degrees. If we're typically in radians, it'd be theta, 0 to 2 pi. Don't worry, instructions would never be this vague. The instructions on a quiz or a test would either look like this and be entirely in degrees, or the instructions would look like this and be totally in radians. It just depends on the problem. Because here it says cosine theta, we're going to use radians, and we're going to answer within 0 and 2 pi. So it's asking you, when is cosine of some angle, the cosine of what angle is negative 1/2? And what we need to remember is cosine is the x-coordinate. So when is the x-coordinate equal to negative 1/2? And of course, I'm going to need to use the scratched out versions that I had here. My x-coordinate would be negative in these two quadrants. It was negative here, and it was negative down here. And we're doing this one in radians, so it's at 2 pi over 3 and 4 pi over 3. So theta equals 2 pi over 3 and 4 pi over 3. I'm just going to do one more of these, number 2. Let's say that it said sine of x, so that's telling us degrees for this problem, equals, no, shoot, let's also go, no, let's go with negative root 2 over 2. So it's asking me, when is the y-coordinate equal to negative root 2 over 2? And I think y-coordinate, the y-coordinate is going to be negative down here in the third and fourth quadrant. I have negative root 2 over 2 over here, negative root 2 over 2 here, and that's at 225 degrees and 330 degrees. So x equals 225 degrees, comma, 315 degrees. That is the time that the y-coordinates are equal to negative root 2 over 2. And that's solving one-step trigonometric equations. Yeah! Everybody, thank you so much for watching this. Have yourselves a great rest of your day. Life is good. Talk to you soon. Bye-bye.